A very good morning and hi to everyone. Today we are going to present about the common concrete problems in concrete house and what is the cause of the problems and how can we solve or prevent them. So these are my group members and I am Yong and I will talking about the introduction, methodology and conclusion part. Concrete house is a building which is built with concrete as its primary structural element. It is made by using a combination of cement, water, sand, gravel, and stone aggregates. It is also combined with various chemical properties so that material can become more stronger and durable. Concrete house construction can be classified into a few groups. The first type is concrete blocks. It is known with its manufacture speed and less expensive price. Concrete blocks can vary and can be used with facings or coverings to create eye-catching home design. Concrete blocks are also an exceptional study material which is susceptible to high winds. The second type is precast panels. Precast panels are produced at concrete plant and it is a little bit more expensive than some of other concrete building options, but it is still have high durability against wind condition. The next type is removable forms. It places insulation and reinforcing steel in aluminum, wood, or steel removable wall forms. With removable forms, exterior and interior walls can be poured at the same time. The construction will become more faster. Removable forms are also a conventional concrete option that is sure to stand strong. The last type is insulating concrete forms, which is ICFS. ICFS are made of extremely dense plastic foam and filled with concrete and steel reinforcements. ICFS creates a highly insulated that can withstand fire and high winds. The steel reinforcement used in ICFS is buried in concrete to protect it from corrosion and rust. The plastic foams are treated with flame retardants to prevent them from burning in the case of a fire. Next, we will talking about the advantage of concrete house. So these are the advantage of concrete house. Concrete house is high durability and highly resistant to damage and abrasion. It is also fireproof. Reduction in energy cost and insurance cost is also lower compared to other types of house. From construction speed, concrete house is comparable to wood frame construction and faster than structural steel. For energy efficiency, concrete is also a good insulator and shows that concrete can help maintain temperatures even during long periods without heat or power. Next, concrete is highly malleable and will perform various types of appearance and additives. It shows that it can be used in various types of projects. Last but not least, the maintenance costs of properly installed concrete are less and with many applications lasting for decades. Generally, there are two common types of concrete house construction, which is tilt-up construction and ICF construction. These are the process during both construction. For ICF construction, ICF block is a good insulator. It keeps that heat in and cool out with extreme efficiency, allowing homeowners reduce their energy bills each month. ICF blocks are extremely durable. They are also perform well against harsh weather conditions. For tilt-up construction, tilt-up walls construct faster and require fewer skilled workers than masonry walls. Tilt-up eliminates the transportation costs associated with masonry blocks and precast panels. Cost of the project will be reduced. Next, we are going to look at methodology. We have collected our data through Google Form survey. Besides, we have also conducted a brief talk about 30 minutes on YouTube. So, we have conducted our survey through 42 respondents from students in UTM. So, after that, we will move to data analysis. So, based on our survey, we found that 19 from the respondents, which is 45.2% of the respondents have found the concrete problem in their college. Another 10 from the respondents have found the problem occur in single-story house. Besides, nearly half, which is 21 from the respondents, have found the concrete problem occur in their washroom. Another 14 of the respondents have found the concrete problem occur in corridor. Last but not least, from the survey, we have also found that 83.3%, which is 35 from the respondents, have faced the cracking problem, and another 52.4%, which is 22 from the respondents, have faced the scaling problem. Thus, we can justify that the most common concrete problem occur in concrete house is cracking.
The first commonly root cause of the concrete problems is cracking. Actually, there are six types of the cracking, which is plastic shrinkage concrete crack, expansion concrete cracks, having concrete cracks, settling concrete cracks, concrete crack caused by overloading the slab, and the concrete cracks caused by premature drying. Plastic shrinkage concrete cracks is happen when the water evaporates from the slab. It leaves enormous gaps between the solid particles. The concrete becomes weaker and more prone to breaking as a result of these weakened areas. For the expansion concrete cracks, concrete expands and pushes against anything that gets in its way. For example, a brick wall or adjacent slab. When neither can flex, the expanding force is strong enough to cause concrete to crack. The next one is having concrete cracks. When the ground freezes, it can raise several inches before thawing and returning to its original position. The freezing and thawing cycle causes significant ground movement, which contributes to concrete cracks. Next is settling concrete cracks. When a void in the earth beneath the concrete surface is established, consider that what happens when a large tree is cut down near you and the root begin to degrade. For the overloading the slab, concrete is fairly robust building material, yet it has limitations. So putting too much weight on top of the concrete slab might cause it to break. And the last one for the cracking is premature drying. Surface crack that resemble spider webs or shattered glass are known as crazing cracks. And the other one is crusting cracks are most commonly seen during the concrete stamping process, which adds texture and design to concrete surface. The second commonly root cause of the concrete problems is honeycomb. Honeycombs are hollow areas and voids left on the surface or within the concrete mass where concrete could not reach. These appear to be honey bee nests. Honeycomb is a concrete caused by improper vibration and concrete workability. Honeycombs on the sides are apparent to the naked eye and can be easily seen once the shuttering is removed. Causes of honeycomb. Do you know why can it happen? Actually, the honeycomb is because of improper vibration during concrete, less covers to reinforcement bars, use of very stiff concrete. Honeycomb are most commonly found at the transection of beams, beams to columns, and one or more beams. This is owing to the jumbling of beam and column rods reinforcement in one location. Special care is necessary during concreting and vibrating at this location. The presence of higher percentage of larger aggregate in concrete hinders concrete from filling tiny crevices between reinforcement rods. The third root cause of the concrete problems is scaling. Scaling is the flaking or peeling of the finer hardened concrete surface caused by freezing and thawing cycles. In most cases, it begins as isolated little patches that eventually mix and spread to reveal broad areas. The coarse aggregate is not visible when light scaling is used. Do you know what is causes of scaling? Scaling is happen because of non-air entrained concrete or insufficient entrained air. For protection against freezing and thawing damage, enough air entrained is required. Even air entrained concrete, however, will scale if other safeguards are not taken. Early age application of calcium or sodium chloride de-icing salts, other salts such as ammonium sulfate and ammonium nitrate might produce scaling and chemical exhaust on the concrete surface, and the finishing procedure carried out when bleed water is present on the surface. When bleed water is forced back into the top of the slab, the water cement ratio skyrockets, resulting in a low strength surface layer. Curing is insufficient or non-existent when exposed to freezing and thawing in the presence of moisture and the ice chemicals. This omission frequently results in a thin surface skin that will scale.
Next common root cause of a concrete problem is called efflorescent. Efflorescent is a white powdery substance seen on unsealed concrete surfaces and a white blush seen on sealed floor. Efflorescence is caused by vapor migrating through the slab and bringing soluble salts to the concrete surface. On unsealed concrete surfaces, efflorescence is typically worn off or washed away. In tough cases, a mild acid rinse or even light sandblasting may be required. Efflorescent trap under sealer is unsightly, and even it is more noticeable on darker floor. So what is the cause of efflorescence? There are two types of efflorescence, which is primary and secondary efflorescence. So the primary efflorescence is caused by water in the concrete evaporating from the slab, leaving soluble salts on the concrete surface. The fact that these salts are actually more soluble in colder temperatures, combined with increased bleed water in cold weather, increases the likelihood of efflorescence appearing. After winter, after winter concrete placement, the use of calcium chloride to accelerate the set time adds to the efflorescence with cold weather pours. High slump concrete and the addition of calcium chloride are major contributors to efflorescence. For the secondary efflorescence is frequently described as water from beneath the slab or water introduced from the surface. Secondary efflorescence is most likely caused by a saturated base material and um, improper drain site or excessive amounts of water used by the decorative flooring contractor during his cleaning process, such as rinsing of acid stain residue when extra mixed water and extra soluble calcium chloride salts are added to to cool cool weather concrete, followed by more water from the decorative processes. Some degree of efflorescing is unavoidable. The last common root of a problem in concrete is called bleeding in concrete. What is bleeding in concrete? Bleeding in concrete is generally defined as the free water in the mix rising to the surface of freshly concrete due to the settlement of heavier particles such as cement and water and forms of cement paste on the surface known as latents. As a result of the formation of latents, freshly concrete structure lose their resistant capacity, strength, and life. The question is that why can it happen? The factors that it can happen, including type of the cement used, quantity of the fine aggregates, improper proportion of concrete constitution, and the most important one, the separation of the constituents materials of concrete in the form of coarse aggregate separation, paste separation, and water separating out in the concrete mix as a form of plastic state in which heavy aggregate particles settle down due to particle settling. Water rises to the top of freshly concrete surface and formation of latents in surface, which plays an important role in the cause of bleeding.
How to prevent and solve. First, cracking, honeycomb, scaling, efflorescence, bleeding. For cracking, the first way to solve the cracking in concrete is properly cure. Concrete takes 28 days to completely cure. The step you take in the first few days after the pour are the most important for ensuring a strong, the crack-free surface. And then cement, the binding ingredient in concrete. Cure gradually and need to retain moisture to reach its full strength. Concrete is less likely to crack if the moisture evaporates slowly. So your project will be much stronger if you spray it with a water a few times each day for the first week after your for the project. And then the hotter and drier the weather, the more often you should spray the near concrete. And then to make life easier, you can eliminate the need to water the concrete and add a quick rate acrylic cure and seal into the missing water before combining with the concrete. It is not make a curing process easier. It also will protect the concrete from dirt, grease, and other stain. And then the second way to prevent the cracking in concrete is mixing the proper amount of water. Even just one additional quart of water can reduce concrete strength by up to 40%. When mixed correctly, wet concrete should be thoroughly saturated but not watery. And then for the honeycomb, the prevention of honeycomb in concrete structure can save time and money and help construct structurally sound concrete members. Therefore, undertaking preventive measures to avoid the overcurrents of honeycomb is of utmost importance. The measures include proper compaction, use of rigid and waterproofing formwork, clean placement of steel bar, adequate concrete cover, and then other than that. And then the way to prevent the honeycomb. First, pour concrete from a suitable height, which should not exceed 1.5 meter. Perform sufficient concrete compaction and prevent over-compaction, which cause concrete segregation and ultimately honeycombing. Make sure to provide adequate concrete cover to facilitate concrete compaction. Secure steel bar at their concrete position properly and maintain designated bar spacing to facilitate both flow and compaction of concrete. And then if reinforcement congestion is inevitable, use self-compacting concrete or any other unique concrete formulation to ensure proper concrete pouring and compaction and consequently prevent honeycomb. Additionally, use a maximum aggregate size of 12.5 mm and then make sure that the concrete around steel bar and other embedded object is compact adequately. And then, when bit a bubble come out of fresh concrete, the application of vibrator should be stopped. Honeycomb is very likely to occur in the corner of concrete structural member. Therefore, compaction in the corner of structure member should be performed sufficiently. Use adequately rigid formwork and seal joint to avoid leakage through them. The leakage may swell plywood, which may modify dimension of the structure element. Make sure that concrete has suitable workability for the condition in which the structure is constructed. For instance, if a column is reinforced heavily, the concrete mix should have a slump value of around 15 cm. A concrete mix a concrete mix needs to be cohesive. And then the concrete mix should have enough fine to fill space between coarse aggregate. Apply the outside of the formwork with a wooden hammer during concrete pouring to reduce the risk of honeycomb. And then for the scaling. Concrete scaling in the local flaking or peeling off of the near surface concrete due to environment factors like freezing and thawing. Other factors that may contribute the initiation of concrete scaling are the use of low-strength concrete, decent salt, and a high water-cement ratio in a concrete mixture. The process of concrete scaling begins with a small patch, but develop and merge with a larger patch and broader area in is not repaired soon. The scaling in concrete can be fixed by cleaning the deteriorated area and refacing the concrete. The way to prevent scaling. First, design concrete mix properly. Use appropriate water cement ratio, maximum 0.45, and well-grade aggregate. Use a suitable curing method. The curing period should be long enough, minimum 7 days, for concrete to gain a strength that can resist scaling. Do not carry out finishing operation when water is on the concrete surface. Prevent the addition of water when concrete is thrown or floated prematurely. Do not perform finishing work before bleeding water come to the concrete surface. So, let bleed water come to the surface and evaporate, and then begin the finishing operation. And then, prevent vibrating scratch for high slump concrete as it creates a weak layer of concrete surface. Avoid the exposure of concrete to corrosive substance. For example, salt like calcium, magnesium, or sodium chloride for near concrete surface. And then protect nearly placed concrete from severe environmental conditions and avoid full saturation of new concrete before pricing and thawing cycle during the winter season. Slope the concrete slab surface properly to drain water. Then saturated concrete is at risk of freezing and thawing and subsequent surface deterioration. And then clean concrete slab surface and apply a suitable waterproofing system every 3 to 5 years to prevent penetration of water and dishing solution.
Next, we move on to efflorescence. It is critical to understand the distinctions between efflorescence and stains. Stains typically come in variety of colors, but they may initially resemble efflorescence. As stated in root and cause, efflorescence is a white powdery substance that can be found on unprotected surfaces. All building materials that come into contact with the ground can be susceptible to efflorescence. Here are some preventive measures that can be taken to avoid efflorescence in concrete. Inclusion of class F, such as fly ash or metakaolin, can lock up significant amount of calcium hydroxide in the concrete. Installing vapor barrier to prevent the movement of moisture from the subgrade to the surface of a slab. As stated earlier, the efflorescence reaction is driven by water, either water from above or below a slab. Only vapor barriers can prevent the movement of moisture from the subgrade to the surface of a slab. Next, application of sealers and coatings can prevent surface water from penetrating slabs. You should apply them as soon as surfaces are clean and dry. Other than that, reduce permeability by using waterproofing agents or making the concrete denser. Low permeability helps keep aggressive chemicals out of the concrete, slows leaching of soluble material such as lime, and limits the depth of carbonation, thus better protecting reinforcing steel from corrosion. Maintaining surface sealers and site drainage and from rising groundwater by placing a plastic membrane under slabs. Avoiding the concrete from premature drying can also prevent the efflorescence on the concrete. Use of concrete ingredients such as aggregate, cement, and sand, which contain very less amount of salts in it. Salt is a mild acid and lowers the pH in the concrete. The acidic reaction attacks the concrete paste and aggregate, weakening the structure and strength of the concrete. It is also increases the pore size, allowing additional water and chemicals into the concrete, which can exacerbate freeze the cycle damage. Last but not least, how to prevent the bleeding of concrete. Excessive bleeding will increase the water to cement ratio in the upper concrete layer near the top surface. This creates a weak top layer with poor durability properties, especially if the finishing operations happen while bleed water is present. Waiting for the water to evaporate is the best approach. If the finisher starts finishing the concrete with bleed water present, the water will be forced into the top layer, severely weakening the concrete. Here are some methods for reducing the possibility of concrete bleed. First of all, add sand. As a fine particle, sand can absorb water. To reduce bleed when using sand, make sure it contains a variety of finer particles. The finer the particles, the greater the absorption. Increasing the sand content and decreasing the coarse aggregate will also help, but be aware of the effects on the strength of design. Next, add supplementary cementitious materials SKMs into your mix. SKMs such as fly ash or slag are extremely fine, often finer than cement. If you incorporate this into your mix design, the water absorption in the mix will increase. SKMs also increase workability, increase strength over time, and a lower cost to supplement of cement. Add air entrainment to the mix. Incorporating more particles into the mix to absorb water or air bubbles is truly significant. Including tiny air bubble increases the surface area that cement and water must cover in the mix, lowering the total amount of free water that can rise to the surface of freshly poured concrete.
As a conclusion, concrete house brings a lot of benefits to us. For example, it is high durability and fireproof. The cost of insurance also lower compared to others. The construction speed of concrete house is also faster than steel construction. Besides, it is also high versatility, which can perform various types of appearance. And lastly, concrete house only need a low maintenance fee on it. However, if we didn't do the maintenance on the concrete house properly, it can cause a lot of concrete problems such as cracking, honeycomb, scaling, efflorescence, and bleeding. Hence, it is important for us to know the cause of the problem and ways to prevent it. For example, avoid the exposure of concrete to a corrosive substance. That's all for our presentation. Thank you. Hopefully the information given will help you to solve and prevent the problem.